Hi everyone, welcome back to my YouTube channel. So in this video we will be learning about minimum spanning trees. So before we learn about minimum spanning tree, let's understand what is a spanning tree. So a spanning tree is a tree with n nodes and exactly n minus 1 edges such that every node in the graph is reachable to every other node and there is no cycle in the tree. For example, if we consider this graph, there can be multiple possible spanning trees. One could be 0, 1, 2, 3, and 4. So the number of nodes in this graph is 5 and the number of edges is 4. So this is a spanning tree, and from every node in the graph we can reach to any other node in the graph. For example, if we consider 0, from 0 we can reach to 1 and 2 and 3 and 4. To make two nodes connected in a spanning tree, it is not necessary to have a direct edge between the two nodes. To make two nodes connected, the path between the two nodes can have multiple nodes in between. It's just that from every node in the graph, we should be able to reach any other node in the graph. For example, if we consider 0 and 2, there is no direct edge between 0 and 2, but still we can still reach to 2 from 0 via 1. Okay, so this is a spanning tree because for every node in the graph we can reach to any other node in the graph and there's no cycle in this tree. Okay, as you can clearly see, there is no path in this tree which contains a cycle. Okay, another possible spanning tree could be 0, 1, 2, 4, 3. So for this spanning tree also there are 5 nodes in the graph and 4 edges. Another possible spanning tree could be 0, 1, 3, 4, 2. Again, for this spanning tree also there are 5 nodes and 4 edges. And from every node in the graph we can reach to any other node and there is no cycle in this tree. That's why it is a spanning tree. Now let us understand what is minimum spanning tree. Okay, so if I consider this spanning tree, let us draw it again. Let us also write down the edge weights in this spanning tree. Okay, so the sum of edge weights in the spanning tree is 1 plus 3 plus 4 plus 5. 3 plus 4, 4 plus 4, 8 plus 5, 13. Okay. Now consider the second spanning tree and write down the edge weights of second spanning tree. One plus 3 plus 5 plus 11. 3 plus 1, 4 plus 5, 9 plus 11, 20. Now consider the third spanning tree and write down the edge weights. 1 plus 4 plus 5 plus 7. 4 plus 1, 5 plus 5, 10 plus 7, 17. Among all the spanning trees, the one which has the minimum cost to connect all the nodes is the first spanning tree, because the sum of all the edge weights in this spanning tree is 13, which is minimum. So this is our minimum spanning tree.